Yeah, looks like that. So let's wait for some people to join in and then we can start. So this will not be that big of a stream. We will just do some casual discussion on ICPC, right? हेलो भाई लोकेश। हाँ, 20 मतलब या 2021 का। लाइक मेरा मतलब थर्ड ईयर वाला है अभी। एंड ग्वालियर पुणे में सिलेक्ट हुए हैं। सो लेट्स सी कहाँ जाए लोकेश, पता ग्वालियर या पुणे? दोनों जगह नहीं, मतलब ग्वालियर पुणे मतलब एक रीजनल ही है, डबल ऑन साइट है। हाँ। हाँ, नहीं नहीं, पर मतलब दोनों एक ही रीजनल है ना, ग्वालियर ग्वालियर पुणे मतलब एक रीजनल का नाम है, डबल ऑन साइट है। एक मैंने पोस्ट पे कमेंट किया था ये वाले। अमृता पूरी उसके लिए साइन अप नहीं कर पाए हम लोग। लाइक हमारी कॉलेज की फैकल्टी इतनी स्लो है, उसको बोला उसने, जब तक मतलब साइन अप किया वहाँ पे पोर्टल पे तब तक दोनों की डेट एक्सीड कर गई थी, अमृतापुरी की भी कानपुर की भी। कंट्रोल एफ, ग्वालियर आई गेस। एक तो ये टीम आ रही है भाई, सब मास्टर है। अगेन सब मास्टर हैं। एक मास्टर है, एक ये भी अच्छी टीम है। ये सब एक्सपर्ट्स हैं डैट वी कैन हैंडल। इसमें भी अच्छी टीम्स आ रही हैं भाई ग्वालियर में। देखना पड़ेगा। तेरे तो, हमारी तो मतलब कॉलेज में टीम ही नहीं है ना। तुम्हारे कॉलेज में तो मतलब पहले तुमसे होते हो, तुम्हारी टीम, तुम्हारे कॉलेज की कोई टीम है एक, शायद मैंने देखी थी। मे भी तू जानता हो, तेरे जूनियर्स होंगे। NIT के, इनको जानता है क्या तू? ड्रोगेंडो, डेल्टा क्यूब, अनिरुद्ध। NIT कुरुक्षेत्र से ही है शायद। नहीं, सूरत कल से है। नेवर माइंड। इजी पीजी तो क्या, टॉप 10 एम कर रहे हैं। बता फ्लाइट से जाएं या ट्रेन से जाएं? So we can start with the first problem, integer on stones. हाँ, मेरी वीडियो लैग कर रही है फॉर सम रीज़न। आई थिंक कॉलेज का इंटरनेट है तो आई कैन नॉट हेल्प इट। तो लेट्स स्टार्ट विद द फर्स्ट प्रॉब्लम। तो क्या दिया प्रॉब्लम में? एलिस लव्स कलेक्टिंग स्टोन्स एंड राइटिंग नंबर्स ऑन देम। Today she has got a total of n+1 stones and is even. She has got an odd number of stones. He wrote the number of the stones in a sequence 1, a square, a cube, a to the power n. The number a would be a non-zero integer, can be negative as well. She arranged the stones in increasing order of numbers. All of a sudden, the middle stone fell down and broke into pieces. She wants to repair the broken stone. To this, she needs your help. Number on the middle stone. Since number could be large, output your answer 10 to the power 9 plus 7. So I think this was the easiest problem on the set. तो इसमें क्या था, इसमें we were given some integer a, right, and integer a was non-zero, right? A was not equal to 0, but a could have been from up to I guess 10 to the power minus 9 to up to 10 to the power 9, right? So range of a was from 10 to the power minus 10 to the power 9 up to 10 to the power 9. So Alice wrote the sequence 1a, a square, a cube, so on, and she sorted the sequence. And then she dropped the middle element, so we have to find the middle element. So I think that is easy enough, right? So we have two cases in this, right? The first case is when a is positive, right? When a is positive, the whole sequence will be increasing. So we will have 1a, 1a, a square, a cube, a to the power 4, so on, right? So in this, your answer will be how much? Your answer will just be a to the power n by 2, or right, you can round off. So your answer will just be a to the power n by 2 modulo 10 to the power 9 plus 7, right, when your a is positive. And when your a is negative, it will alternate, right? It will alternate. So let's say your a is negative and your modulo value is mod a. So your sequence will be something like this. Your sequence will be, you will have 1, then you will have modulo a, then you have modulo a square minus, or you will have minus on the left side. You will have positive a square on the right side. You will again have minus a cube, you will have a to the power 4, and so on both the sides, right? So your 1 will always be the middle element, because all the terms on the left side will be negative and all the terms on the right side will be positive, right? So your 1 will always be the middle element. So if your a is negative, you can just print your answer as equal to 1, and that is your solution. Okay, bye bye Lukesh. So let's move on to the second problem, that is operations on a binary string. I think it was also easy. So Bob has a binary string S of length n and x coins. Bob can do the following operation any number of times. Select a continuous substring of size this and flip all the bits in the chosen string. The cost of this operation is 2 into k plus 1 coins. Help Bob find the maximum number of ones after doing some operations at the string using at most x coins, right? So the second problem, we have been given some sort of a binary string, something like this. You can select any subarray and flip the bits, and the cost of flipping is 2 into length of subarray. So let's say length of this is equal to k, it will be 2 into k plus 1. In this example, we are choosing, let's say, this subarray. So our size is 4, so it will take us 2 into 4 plus 1, so it will take us 9 coins. And we want to flip the array such that you will have maximum number of ones at the end. So how can we do this? So in this, a very important observation is that it is never optimal to flip a 1, right? It is never optimal to flip a 1. For this, I can give you an example. Let's say you have 0, 0, 1, 0, 0. So after graduation, is there any coding course like ICPC? I don't think so. Like, you can still go for Google Code Jam, right? Code Jam or Hacker Cup. They are not for college graduates. So you can go for Code Jam or Hacker Cup, yeah. So in this, what you can do is, if you flip this, it will take you how many coins? It will take you 2 into 2 plus 1. So it will take you 5 coins, right? So 2 elements for this and 1 extra for the operation. And if you again do this, it will take you 2 into 2 plus 1, right? It will take you how many? It will again take you 5 coins. So in total, it will take you 10 coins. But if you flip a 1, we have 0, 0, 1, 0, 0. So if we do this, right, it will take us how many? It will take us 2 into 5 plus 1, right? So it will take us 11 coins. And in the end, you will also have 1, 1, 0, 1, 1, right? Because you have this 1 and flipping this 1 is adding extra 2, right? So instead of flipping this 1 to add extra 2, you could have used that extra 2 in the following operations, right? So it is never optimal to flip a 1, because after you flip a 1, you also have to flip it again to 0, right? So it will just like cost you extra coins. So it is never optimal to flip a 1. So your solution is just find contiguous blocks of zeros, right? And start flipping these blocks until you run out of coins. So I hope that is easy enough. So just like iterate over the array, iterate over the string and find the contiguous blocks of zeros, and like just apply operations on those blocks until you run out of coins. So that was this problem, right? So we have solved 2 problems up till now. Let's move on to the third problem. That is red and blue. I have not read this problem, so let's see how it is. So Bob has a string S of length n in which each character represents a color either denoted red or blue. He also has an array D of length n where each element is a non-negative integer. So in one move, Bob can select any index I between 1 and n and spill the color Si from index I plus 1 to I plus Di, both inclusive. Okay. That is, characters at indexes I plus 1, I plus Di are set to Si if Di is greater than 0. Bob wants to make the entire string red in color. That is, all characters S should be equal to R. Help him find the minimum number of moves to do so. If this is impossible, print -1. Okay. So we have been given a string. Let's say RRB. And we have 2, 1 and 0. So we can apply an operation on this part and color the following part, right? So that is it. So what we can do is we can, I think, apply binary search on this as well. So like I can if this is equal to 2, I know that it will color, because I will always apply operation on red ones, right? So I know it will color all the elements up to this point. So it will cover all the elements up to which point? It will cover all the elements up to to how much? It will cover all the elements up to, if this is my index I, it will cover all the elements up to I plus 1 to I plus Di, right? So maximum range of this is equal to how much? It is equal to I plus Di, right? So I know it will color up to these many elements. So obviously I want to color my last element as well, right? So first I can look for the element that will color up to my last element, right? Now I want to color up to this element, so I will find some element that will color up to this element, right? And so on. So that is what I think will work. Yeah, some kind of binary search will work for this, right? So you can find the maximum number up to which a red cell can color, and then you can, for every black cell, find which red cell is required to color this, right? And I think that will work. If there are multiple, you will always select the one that has the highest range, right? Yeah. that will work. So that was it for this problem, red and blue. And let's move on to the fourth problem, that is Lexus. So in this problem, you were given Bob as a string of length n consisting of lowercase English alphabets. He can select some possibly non-zero, non-overlapping substrings. Several substrings are strictly increasing in lexicographic order from left to right. Bob has an array A of length n where AD is the score he will earn for every substring Bob picked that has a length D. Find out the maximum score Bob can get. Alright. So what you can do is, in this case, you can, like, there will be, our n is up to 500. So what you can do is, you can use a try. There will be n square substrings, right? There will be n square substrings. So you can insert all the substrings into a try. So it will take you O of n cube time, right? O of n cube complexity to insert all your n square substrings into a try. And after you have inserted them into a try, you can use the try to sort them, right? Sort them out. And after you sort them out, you will have some kind of, right, an array of strings. So you will have n square strings, and then you can use a O of n cube dp. Or you can just use O of n dp. That will iterate over the n square elements, right? Yeah. So after this, you will have all the strings in sorted fashion, right? You will have all the strings sorted in lexicographical fashion. So what you can do is, for example, you can have something like A, BA, BAD, CC, right? So you will have something like this. And you will also know the endpoints or the starting points of these. So you will know this is 1,5, not 1,5, this will be how much? This will be 1,1, this will be, let's say, 2,3, right? So it will start at 1 and end at 1. It will start at 2 and end at 3. So something like this, right? So to find the answer for this, your answer will be how much? It will be all the lexicographical string that are smaller than, so the answer for this is dp of 1 is equal to how much? Dp of 1 is equal to dp of 0 plus score of this string. Or you can say, if this is your starting point and this is your ending point, then you can say your dp of end is equal to maximum of dp of end and dp of start minus 1, I guess. Dp of start minus 1 plus score of your current string. And I think that should suffice, right? So that was this problem. How long have I been streaming? For 20 minutes, yeah. So now let's move on to the last problem that I'm going to solve. The other two problems were out of my league, so I won't be solving them, right? So let's move on to the the last problem. So the second last problem was a beautiful array, right? I think this problem was much easier than Lexus. I don't know how so many people got this, but I think beautiful array was much easier than Lexus. Yeah. So in this problem, what you had to do is, you were given some array, right? You were given some array, a1, a2, a3, so on up to an, let's say. And value of a1, an was how much? The value of n was up to 200, right? So all the elements ai were up to 1 from 200 and n was also from 1 to 200, right? So you were given a condition. You had, I think, two operations. Yeah, you had two operations. In one operation, you could either swap value of any AI or AJ, or you could have set AI to any integer value x. Right. So these are the two operations, and you had to use these two operations minimum number of times, such that in the end your array A is such that your no element AI is equal to AI plus 2, and your no element AI, so all your elements AI are equal to AI plus 3, right? So you had to do this operation minimum number of times to make the array follow these two conditions. So how can we do this? So we can try to draw an example array and see how your final array will look like, and then you can apply operations on your starting array, right, to make your array something like similar or stuff like that. For example, we have A, right, and I know that my AI should not be equal to AI plus 2, right? So if I have A here, this is, let's say, my value A1, A2, A3, A4, A5, A6, A7. I know that my A1 is not equal to A3. I know my A1 is not equal to A3. So let's say my A3 is some other value. Let's call it value C, right? And I also know that my AI is equal to AI plus 3. So I know that my A1 is equal to A4. I also know my A1 is equal to A4, right? So value here should be equal to A. Similarly, I have no info about this value A2, so I will not think about A2 for now. But I know that my value A3 is not equal to A5. My value A3 is not equal to A5. So let's call this some new value B, right? And I know that my value A4 is equal to my value A7, right? So here it will be A. Similarly, I know that my value A3 is equal to A6. So here I will have equal to C. And similarly here value B will be equal to B here, right? So you can see we have a pattern where we have values in form ABC, ABC, and we'll again have ABC and so on, right? So in the end, your array will look something like this: ABC, 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 something like this. So basically, if we have index A1 here, let's call it A0. We have index A0, A1, A2, A3, A4, A5, A6, A7, A8. So basically all your indexes where AI modulo 3 is equal to 0, you will set your value equal to A, right? We have A0, A3, A6, A9, so on. All your values have to be A here. Similarly, for indexes where AI modulo 3 is equal to 1, that is A1, A4, A7, A10, so on, your value should be B here. And similarly, for AI modulo 3 equal to 2, your value should be equal to C, right? So that is what I want to accomplish. So how can we do this? So in starting, you will have some, so our value of n is up to 200, right? So what you can do is you can iterate over all possible values of ABC, right? Because initially we don't know what A, B, or C can be. So you can iterate over all values of A, B, C such that A is not equal to B is not equal to C, right? So you can do that. And if we know value of ABC, right, we will have some values here. We will have A, some random elements, X, X, Y, some B's here or some C's here. Similarly, in second group, we will have some B's, then some Z, W, some, let's say, A's here, and some C's here as well. Similarly, in the third group, we will have some C's, some V, P, let's say, right? And then you have some B's here, some A's here, right? So we can swap values, right? So you can first swap some B and A values. So you can swap the values of B and A in the first two groups, right? Here I modulo 3 is equal to 0, I modulo 3 is equal to 1, I modulo 3 is equal to 2. Similarly, you can swap value of C and B, and similarly you can swap value of C and A, right? So you can make swaps between elements. After this, you will be left with some elements, right? So in the end, you can have some elements like this. For example, you will have A. You can have some leftovers B here. You can have some leftover C's here. And you can have some leftover A's here, right? So in this case, right, after doing the first set of swaps, right, you can have some element, you can have some configuration like this. And in this, you can swap now these B, C, and A in two swaps, right? So first you can swap this B and C. Now you have B in the right place and you have C here. And then you can swap this C and A, right? So you can see this kind of forms a cycle, right? So if we have B, C, and A, you can first swap this B and C, and then you can just swap this C and A. So it kind of forms a cycle, right? So you can swap three elements in two swaps, right? So first of all, you will do the normal swaps, and in the end, check if you have some kind of cycles, then look for cycles, right? And after you're done with the cycles, now you have some leftover elements, right? These x's, right? And they will never contribute to your answer. So you can use a second operation on them. So whichever elements are left, just use the leftover operations to make them equal to A, make them equal to B, and make them equal to C. So first do the normal swaps, then do the cyclic swaps, and then at the end, change all elements not equal to A, B, and C, right? So then you can like add the answer in all the steps. So you have answer is equal to step 1 plus step 2 plus step 3, right? So there are 3 steps. When you change all the elements, this is your third step. Cyclic swaps, your second step, and then the normal swaps, that is the first step, right? So your answer will be the sum of all these steps. And then there are also some like corner cases. The corner cases were the one thing that did not let us get a AC on this problem, right? So the corner cases are where your n is equal to 2, 3, and 4, right? For example, if your n is equal to 4, you will have your 4 elements, A1, A2, A3, A4. So you have your A here. You know your A3 is not equal to A1, so you will have your you will have your C here, and your A1 is equal to A4, so you will have your A here. But now you have your A2, right? So your A2 should not be equal to A. Your A2 should not be equal to A. So you can say you can put B here, but right, it is not easy to put B here, right? Because now you no longer have your A5. Now you no longer have your A5, right? A5 was telling you that A3 is not equal to A5 and that C is not equal to B. But right, as A5 is no longer there, the condition that B is not equal to C is no longer there, right? So this B can be equal to C, right? So now you have 3 variables, A, B, and C, where A is not equal to B and A is not equal to C, but B can be equal to C, right? So you need to take care of these corner cases where n is equal to 2, 3, and 4. So if you take care of them, then you will be able to get the solution, right? So these were the 5 problems. The other 2 problems are quite hard, so I will not be going over them because I also have no idea how to solve them, right? To be honest. Yeah. So that was it for the ICPC prelims, and I hope we do good in the regionals as well. So hopefully I will see some of you guys there. Yeah. So that is it. And if you guys have some doubts, do let me know or join my Discord server. I'll be more than happy to answer your doubts there. Yeah. I'm not seeing some chats. Like, is the stream okay? Yeah, so I will be like ending the stream. So let me know if you guys have some doubts now before I close the stream. Yeah. So thank you everybody for joining in, and I will see you guys at the regionals, I guess.